What's up, everyone? This is part 2 of the motor mount. Stay tuned, check it out. Hey, what's going on, everyone? So it's been a while since I posted a video. I've been working on the motor mount, and today is going to be part 2 of the motor mount. I mean, honestly, if I think about it, I probably did a little bit overkill here and spent a lot of time, more than I should have, on this. I mean, I basically designed a piece of metal that holds, it's a bracket that holds the cross member beam that I showed you in part 1 with the motor. And that could have been achieved just by a scrap piece of sheet metal. But the reason why I did this was because I wanted to learn a lot more about CAD, because I know as I progress towards this EV conversion, there's going to be more needs to fabricate different types of custom pieces and things like that. And so I kind of pushed myself to learn Fusion 360. And so this video, I'm going to kind of walk you through kind of my thinking, how I did it, and then kind of show you how that turned out. Yeah, I mean, yeah. So first of all, you might ask, why Fusion 360, not SolidWorks or anything like that? Simple answer, I have a Mac. SolidWorks only works on a PC, so the free version of Fusion 360 works, and it's easy, and I'm using SendcutSend. When I export the files to SendcutSend, they fabricate the pieces, so it's pretty easy. Well, there's a couple hiccups I'm going to show you, but yeah, let's dive in. I'll show you kind of what step 1 of the iteration looks like. Okay, so this is iteration number 1 of my motor bracket. So the way this works is, if you remember, I have, so the motor, the back of the motor, the bell housing of the Hyper9 has these 4 holes, I believe are 3/16 size. So what I did was I started, and by all means, this isn't a tutorial on Fusion 360 or anything, but I'll give you a basic, but you shouldn't learn it from me. I spent many hours looking at YouTube videos on Fusion 360, and I'm going to give you a caveat. If you've never used this before, it is kind of a pretty steep learning curve, at least for me. The hardest part was selecting different types of areas to do things. But, you know, it just takes a lot of hit or miss kind of experimentation. And it's not like, you know, like Adobe Photoshop or Illustrator and like that, where it's kind of more intuitive, where you can select things and edit and modify things. This is like you have to kind of figure out, the interface is challenging. But anyway, so this has 2 pieces, has 2 sketches. The first sketch, what I did was I basically made a rectangle here, and I measured based on that sheet metal that I had example, I measured from this hole to this hole, and this hole is the crossbeam member that I drilled in, and then this is the hole for the bottom of the motor. And so I measured that out. Sorry, no. The first thing I did was I created these 4 holes. So I figured out the diameter or radius, the radius from the center of the motor to the holes. And then I used, I forget what it was, one of the tools here on Fusion 360 to be able to place 4 different holes or dots around here. And then I was able to extrude one of these holes, one of these dots, to make the hole, which is a 3/16 size. The other ones, I had a really hard time. I spent like 4 or 5 hours trying to select it and trying to extrude. It just wouldn't do it. So finally I used the hole tool to do that. So anyway, so the first thing I did was I created this. I measured generally how big this bracket needs to be. Okay, so how wide I want it to be, and how the length of it. And then what I did was I sketched out, okay, well, if I put, this is my center point, and how far is it from here down to these 2 holes? And so then I made, this is the center point with the radius, and I was able to figure out where these 4 go. Okay. Then what I did was I I cut a 2-inch hole in the center. This is where kind of the sensor is. I could have probably made it a little bit bigger, but I just want to see just how it looks. And then I put these 2 air vents here. Okay. And then what I did was I created some more 3/16 size holes on the top of the bracket. And then finally, what I did was I used the, I believe it was the, hold on, let me go with create. Yeah, I used the spline tool to create this rounded spline that kind of comes around and meets the outer this is this circle represents the circumference of the actual motor, so the size of the motor. So this one is 6.875 inches across, and so then I was able to extrude these 2 pieces off. So oops, yeah, so once that's done, those were extruded, and so this became my template. This became the motor bracket. Now, because this was like the second time I've ever used Fusion 360, SendcutSend is really cool in that you don't have to use metal. If you don't want to, you can choose acrylic. So I exported this as a step file just by going to File, Export, and then I chose Step, right? Or maybe it was STL, sorry. Okay, one of those. And then so that I was able to upload into SendcutSend, and I made a clear acrylic in the thinnest possible. So it was pretty cheap. It was like $30 or something like that. And after about a week or so, I got it. And then yeah, and I'll show you a video how that looks. All right, so the acrylic prototype's in there, and looks like I'm a little bit off on my cut here in the holes. I got to lower this a little bit, just make sure it's level. But maybe I'm gonna have to adjust the height a little bit. Move these air holes out a little bit, and the design is gonna have a weld of an L bracket that kind of comes up down the center. Okay, cool. So after I took that plexi, I made some adjustments. So this is version 2 of my CAD. Remove the air inlets. I put some slits here for the ribs, which I'll show you in a second. Added in a couple of 3/16 holes. Adjusted the height so it's a little bit shorter, so this doesn't overflow across the cross member beam. This should be flush against it based on the measurements. Okay, and then I'll show you, this is the ribs that I kind of designed. So 2 of them. Okay, so this goes into the slot. And so the way I made this, again, I'm not a Fusion 360 expert by any means, but which was really cool. It took me a long time to figure out how to do this little piece here. And so this was actually just a flange. So I started off with a square piece, a rectangular piece like this. I did a flange that went up 90 degrees. Then I took the conic curve. And then I created this kind of a nice little like bend here on the top. Which was I measured 2 inches. This was 1 inch down, I believe, to where the slits are, and this whole slit is 1 inch. And then I did a flange and kind of extrude that, or I think it was a flange, and I just adjusted the length. And then I sent this to SendcutSend, and it came back with a bunch of errors. And so I had to make some adjustments on this actual piece. So this is tricky. This is how you kind of select that flange right there, and then you can edit feature. And so yeah, they said the minimum had to be this reference, and then you had to change. You had to override the relief. The relief width had to be changed, and the depth had to be changed a little bit to fit. Bend override was okay. So these are things I had to change based on what they said. And so that kind of delayed another kind of a week going back and forth with their support, but their support was amazing. So thanks for that. And then I created a mirror image of this where this is kind of flipped, where this is on this side. So then I get 2 of these ribs, and yeah. So this is kind of what it's going to look like, preview. And now I've marked these 4 holes, so I gotta drill into the cross beam, and then secure the bolts, and we're pretty good. And then we're gonna weld in these All right, so here we are, the finished product. I got the bracket drill holes installed or drilled. Put some temporary bolts in there for now. That's going to be updated. I do need to weld those ribs in, but it's looking pretty good. I think, yeah, these are going to be able to stand some pretty good shocks and stresses. I have underneath here, we have some rubber motor mounts, if you remember, so that kind of that dampens any type of stress from the road. And yeah, I think we're going to be pretty much ready to go. The next step is going to be doing the battery box and electronics, but pretty happy with this end result of the motor bracket. Looks good. All right, I'll see you in the next video.